Okay, Damiaan, you are the last speaker for this summit, for our 2-day summit. You are a developer advocate specialized in machine learning at IBM, and you are going to talk about, well, actually you're going to take us through the day of a data scientist while discussing a case, right?
Yeah, sure. It's actually taking you through about 6 months of being a data scientist, these past 6 months. But yeah, I'll try to focus on the actual job that you have as a data scientist. Sure.
Right.
Yeah.
Cool. Can you maybe start with a little background, just in like 1 or 2 minutes, and then you can just go ahead with your presentation.
Yeah, sure. So yeah, I've been working at IBM for quite a while, almost 25 years to be honest, in several jobs. So I studied artificial intelligence in the early 90s in Utrecht, when cognitive artificial intelligence as a study was just starting. I was the second group to study there. So I finished that in 1995, and since then we had from our study already some contacts within IBM, because they were already doing some advanced data analysis. Not many people were doing it at the time, because it wasn't really feasible to do it on your own system. So you needed a big machine, a lot of iron to do the right kind of analysis. So yeah, after my studies, I applied at IBM, and actually had quite a job convincing the people at IBM that something like data mining would be important at the time. But it took me a couple of months to get in there. But then I talked to the right guy, and he said, yeah, this is what we need. So let's go ahead. So since then, been working at IBM in services, started in services, lots of customer projects, analyzing data for customers, doing some of the advanced stuff that we now call data science. And spent a couple of years in software group in a more commercial role, being responsible technically for the SPSS software that IBM acquired. And the past 2 to 3 years, I'm a developer advocate. Yeah, which means I do sessions like this, with all kinds of audiences, trying to inspire people to work with all this technology, and eventually, obviously, because IBM is a commercial company, maybe convincing them to do that with IBM technology. So there you go.
Okay, thank you very much for this introduction. Well, you can just start with your presentation. I don't know, are you going to use slides or?
No slides. It's all live coding. Everything runs online. So what I show you is running live on my system here, and I'm presenting it to you. So that also means if you have a question when I'm, for example, showing a country or showing something, and you say, okay, can you show it in a different way or something else? We might even try to do that live. But then again, it's only 40 minutes, so it won't be much of that possible. But we'll see what we do. So yeah.
What I can do is, like, halfway, I can ask you 1 or 2 questions, and
Sure.
then we can do 1 or 2 questions more at the end. Is that okay?
Yeah, fine with me. Yeah, and I'll try to keep an eye on the chat and the questions as well. If something pops up that I could answer easily directly, I will try to. Okay. So I'm looking sideways at my screen where the presentation stuff is, where my notebooks are running. And when I'm looking this way, I'm looking at the chat. So so there you go. Yeah.
Okay, the screen is yours, so go ahead.
Yeah. I'll just share my my environment with you. Right, there you go. So you should see something that looks like a Git repository.
Yes, we see it.
If you've never seen one before, don't worry. I'll try to do this as an introductory session. But yeah, there will be some more advanced stuff as well. So yeah, keep asking questions, and we'll see what you can get out of this, because that's what it's all about, I guess. Right. So yeah, what happened? So I told you my day job at IBM is well, more or less doing sessions like this. So for the past 6 months, doing them online. So this is not the first one. I've done 20, 30 sessions on this in the past 6 months with I guess over 1,000 people attending by now. So if I'm going too fast, because I've done this lots of times, please raise your hand and tell me to slow down or explain a little bit more. Yeah, so in the beginning of the year, I was looking for new material for workshops for this year. I usually present stuff that I built myself to explain to people how this stuff works and how you can work with it and be successful with it. So I was looking for new material and looking around, and then obviously the Corona crisis broke out in China, starting then at that time. Already starting a little bit in the Netherlands. I remember that I did a session on the last Friday of February together with somebody from Red Hat when the first case was announced during that session. So somebody picked up his phone and said, we have a Corona case in the Netherlands. So that was the last Friday of February. So that, yeah, it all got quite exciting at that point. But also for me, it got a little bit dull as well, because we were all asked to work from home as at IBM, as everybody, and still working from home. Luckily, I have a good office, home office, because I already worked 1 or 2 days from home at the time. Yeah, looking for new material. So it was, yeah, quite logical that I would look into COVID data. I mean, I'm a data scientist by profession, but it's still a big hobby of me as well. So I just started looking for data and see what I could get from it. At the same time, my wife, who's a nurse, was starting to get very busy at our local hospital, working with Corona cases. So she was in full isolations for a couple of days per week. So yeah, I was also thinking, what can I do as a data scientist? Can I, from that data, do any kind of contribution to relieving all the problems that started cropping up at the time? So yeah, I just fired up an environment, started a repo on Git, and started working on this stuff. So the first step was looking for data, as usual, which is pretty usual as a data scientist, starting at a project. Where's the data? So one of the first sites that had available data was the European Centre for Disease and Prevention and Control, the EU CDC, which is basically, if you're from the Netherlands, we have the RIVM. So this is the European RIVM. And they already had a daily updated file with Corona cases worldwide. And that's one of the first things I thought. I need data from as many different situations as possible, because if you analyze data and you only focus on the Dutch data, anything that you get from that will only work in the Dutch environment. It's usually not very well generalizable. But if you start with data from all around the world, and you find similarities between, let's say, Finland and New Zealand and South Africa and Brazil, then it's probably something that is generally true about disease outbreaks. So I try to start with a relatively limited data set, just case data, but a broad range in the data, and that's always a good starting point. So yeah, it's basically there's simply an Excel file available here, so you can simply download that. It's an easy format. It's also available in text formats, but at the time the text formats were not very stable, so I started out with the Excel data. Yeah, and I just fired up my own Jupyter Notebook environment. You may have seen this before, probably have, I guess, if you're in this session. But yeah, it's the tools that the typical data scientist uses as open source tools. And to be honest, at the time, I didn't have that much experience with Python and notebooks and stuff. I have a lot of data science experience, but with lots of other tools. So for me, it was also a deep dive. Finally, I would almost say at that point into Python and notebooks, and how does this stuff work? So yeah, fired up a notebook, and I always try to set up these kind of environments as where one module or one notebook in this case tries to pick up its own data, does something with it, and produces an output file. Yeah, because you can tweak around in the notebook to get the right kind of output. And after you've finished, you've got something that you can put into a production pipeline. Like, it takes up data, it does its stuff, it produces an output file or output information, and then the next notebook can run. So that's always advisable to start at least in this way. So this notebook simply downloads the file that we just looked at. It downloads the Excel file. A couple of basic stuff like using the right libraries, pandas for data manipulation, NumPy for numeric stuff. It's not new if you've worked with this kind of stuff. And then yeah, let's have a look at what the data is. Always the first look at data, which is for me always an exciting moment. Open up the data file and what's in there. So yeah, I decided to start with as simple data as possible. So what I decided was to use the dates reported, which is a date column here. I looked at the cases in the first case. Because that was the most stable data at the time. We can have a long discussion about the reliability of these figures, but we won't get out of that in before 7, I would say. So let's say I just picked 3 columns: the date reported, the number of cases on that date, and then some kind of region, some kind of dimension that you have in your data. And I chose the GeoID because that's an ISO standard, and it should be fine, and it should be unique, and there shouldn't be no problems with that. And mind you that I say should, because obviously there are problems with it. There's always problems with the data. So yeah, I just started ingesting this data. Yeah, you run into all kinds of problems. I mean, even with this kind of data, which is neatly curated, and people look at it and try to take care that it's also always fits. But then, for example, which is one of the first thing I ran into, there's a country called Namibia, and you can guess the GeoID for Namibia, which is NA. And then you find out that the pandas read Excel, which I used to read the Excel file. By default, every cell where there's an NA is read as not available, as missing data. So that's the usual stuff. It never works out of the box. You pick up a data file, somebody tells you exactly how it is formatted, and it is not formatted like that. There's always problems in there. Suddenly, if you have a comma separated file, then the next day there's semicolons instead of commas. The quoting isn't right. There's always stuff that you have to solve. Yeah, and I think that's one of the most important aspects of being a data scientist, is always being curious about that. Always thinking, how does this work? Where does this come from? Why do I have missing values? Never just assume and just say, yeah, there's some missing values. I don't care. Let's just go on. Try to find out why, and because that learns you a lot about the organization that you're working for, the data where it came from, the process where the data comes from. So it's always very, very important to stay curious and really want to know what's going on here. So yeah, one of the first things here, Namibia, which in an NA country. Yeah, then you do some checks on the data. So it's always checking. That's something that's become part of me in the meantime. So in this case, I look if all the columns that I want to use, the date reported, the cases, and the GeoID have all their values present. So is the number the same? So I miss a couple of lines for country territory code. The population data for all the countries isn't known. But for the columns that I need, I've got all the data. So it's always checking. Even if somebody says there's no missing data, still check, is there missing data? How much is it? Why is it there? Where does it come from? What does it mean? That's always something you're busy with. And that's, to be honest, something you should really like doing. If you don't like that, if you think, wow, all that messy data, what do I do with it? You might think again if you really want to be a data scientist, because this stuff happens. It always happens. And if you get sad from that kind of stuff, you may get sad for quite a while in your career if you start working on this. So that's just a little warning. But yeah, I live from this stuff. I always want to know, why is it there? Where did it come from? So yeah, checking always. So here again, I'm sure that I took out all the missing values, and then still I say, okay, do I have anything that is missing? And I need to have an empty table here, because otherwise I missed something. So always, even if you correct it for everything, still you check if it's still correct. Yeah, so then we have this data set, 3 columns, countries in the column, and I would like it in a different format, because for analyzing it's not that easy. I would like to compare countries next to each other. So what do? You manage your data, so you get this kind of format for this kind of analysis, which is the easiest. There's a pivot statement. So yeah, what I did is I pivoted the data around. So now I've got 2 big slices. One of them is the cases. I also made a slice for deaths to compare those to each other later on. Every line is now a date, so I should have unique dates as a line. So every line is a date, and the countries are in the columns. So you can already see stuff here. For example, you see that AD, which is Andorra, small country in Europe, did not deliver any data for the last day of last year. It's not available. But the Arab Emirates, for example, they did already report data, but they reported 0 cases. So here you've already got something where you can think, okay, what's going on here? Is this important? Do I need to look at this kind of stuff? So yeah, this is just a couple of examples. There's lots more, but I won't go into all of them because of time. But I think the message is clear that already from an overview like this, you can start asking questions to the people where you got this data from, and that is crucial in your work as a data scientist. Never just ignore that and think, we'll see later on, because it will cause problems afterwards, and you won't understand your own results or anything. So start asking questions right away. Yeah, so there you go. So yeah, a little bit of description, and then yeah, straight into graphs, which is pretty easy. If you've got your data in that kind of format, you can simply attach a plot to it, and it will draw a line graph for you. So that's the next step that I always take. Start visualizing stuff. What does it look like? So here you got all the case data for the Netherlands. This is the first wave in the beginning of the year, and these are all the cases that we are measuring right now. And then the question right away is, what exactly is displayed here? This is not infections. This is a representation of infections. What this actually shows is the number of cases that were tested positively. That is what you show. What is shown here. That should have some kind of relation to infections. We all hope, but that is exactly what's showing here. So that's always something as well. Be very precise in what you show and what you're actually are analyzing, because this comes out of a process, and that process hides the actual reality. The actual reality is people getting infected. There's a process of measuring that, and what you get here as an analyst, as a data scientist, is the output of the process. So there could also be all kinds of process effects in here, which are not in the real world, but yeah, this process is between you and the real world. So you have to find out what's going on there. Typical example here, if you look at the disease data for the Netherlands, you see this big sawtooth effect where there's, if you zoom into this, there's always many more cases reported on Tuesdays. So are actually people dying more on Tuesdays? No, they're not. It's the reporting process where people that die over the weekend are usually reported on Tuesdays. So yeah, that's something you see, and something you should wonder, something you should even worry about, and try to find out what's going on here. So never just look at this graph and say, okay, so this is the trend. No, look at the details as well, and really try to find out what's going on here. So this is just an example, but you'll run into all this kind of stuff when you start working with real life data. So yeah, all kinds of visualizations. So all this stuff is available. So if you are already a bit up to speed in these kind of environments, we'll share the Git page with you. Which is pretty simple. It's just gitlab.com/Zwietering/corona, which you probably can't read, but we'll send you the link. So all this stuff is freely available, so you can run this for yourself. So I would almost say have a look. Yeah, so this is process stuff. What comes out of the process? This is typically dirty data. When we look at the graph for China, in this case, where somewhere in February they found out that they had 15,000 cases reported, but they did not have a date for those cases. So what they decided is, yeah, we'll just put all these cases on one date. And if you then draw the graph, you get this kind of weird spike here, where within a reasonably nice curve that you have, you suddenly get this huge spike of 15,000 people. So yeah, you have to deal with it. You can ignore it. You can spread them out over the days around, but you have to take some decision about that. And usually, you can't take the decision yourself as a data scientist. So again, communication is essential here. Talk to the people where this data come from, and discuss with them how to deal with that. You can't just decide on your own just to ignore those cases, for example, because then your totals don't add up anymore. Your graph looks a lot better, but in the end you miss 15,000 cases. So yeah, so even if you do that, at least document it and communicate it, but you should discuss it. Yeah, so there's a lot of stuff there. There's a lot of checks in here. I always say, if I get this kind of data in a graph, I start checking my own process of manipulating the data to see if this is really there in the original data. It might be that I made an error, which causes this peak. So here I look at the original data file, and I see indeed that on the 13th of February, we had this huge number. So it's actually there, which is also something that you should always check before you start discussing where does this peak come from. First, check if maybe it's you that caused it. But that's general tips. Yeah, so lots of graphs. You can do logarithmic graphs. We won't go through all of them, so be my guest and have a look at them. You can look at relative cases compared to yesterday. So how fast are the cases still rising for countries? You can look at the amount of days that it takes for the amount of cases to double. It's all kinds of measures that I found in articles and found in papers, but also just in the news, where I just said, okay, can I reproduce them with the data that I have, which is also always a very good verification. If I see the graph for the Netherlands and I take my own data and my own process, do I get the same graph? That's an important one before you even start modeling. So yeah, lots of stuff. And I first looked at, can I say something about the severity for the care system? So how hard is our system actually hit by this outbreak? And then you have to understand what the shape is of such an outbreak. So for example, here I've got two of them for the Netherlands and for Belgium. And yeah, you can see that they have a more or less similar shape. There's a steep rise, then it plateaus, and then you also see that the tail of this distribution that you see here is a bit longer than the start. So yeah, I found, for example, that people assumed this would be symmetrical. So they said, okay, if we have this rise, we also have probably have the same kind of tail in the distribution, but obviously that wasn't true because we see this all over the place. I've looked at, well, in this case, 180 countries and lots of different outbreaks in regions as well. And you always see this similar shape in the outbreak. So yeah, my next question was, what does the shape look like? Because then if you know what the general shape is, and you have the rise of the shape in a country or in a region, you might be able to predict the rest and do a prediction about what would be going on there and how many people would be infected, probably, how hard would the care system be hit, stuff like that. Yeah, so I looked really into distributions, and we won't go deep into that because that will take quite some time, and it took me 2 months to find out how this exactly works. So I found a kind of distribution which is called the gumball distribution, which describes in a very general way the typical shape of outbreaks like this. So for example, you see a couple of examples with different parameters, and you can see that this kind of shape, for example, the blue one here, looks very much like a disease outbreak that you typically see. And believe me, I've looked a little bit better than looks similar to. I dived into the mathematics and really looked if this would be a feasible way of modeling. Yeah, and then if you really dive into the theory, and I learned a little bit about epidemiology, which is also usual as a data scientist. When you dive into the data of a certain subject, you have to become a little bit of an expert in that subject as well to understand what the data is about. So I really dived into that, and at a certain point you say, okay, I've got enough evidence that this is probably the way that this stuff looks like, that it's probably modeled or measured. And then I'm going to turn around the assumption, which is typical data science activity. And I'm saying, okay, now I'm going to assume that this is the right way to do it. And then I'm going to see if I can fit that to my data. That's usually what you do. So you look at the data, you look at the theory and the process behind it, then you form some kind of assumption in your head. I think it is working this way, and then you test your assumption. I mean, that's basically, that's almost, I would almost say that that's the science part of data science, to approach it that way. So yeah, doing that, I just looked at, can I fit the data at least partially for several outbreaks, several countries with the original data, and yeah, it worked pretty well. So if you look at, for example, the fit that I did to the first outbreak in the Netherlands, according to this gumball distribution, at least visually, but there's a lot of measures behind that as well, where you can see how well it fits. At least visually, it looks pretty good. I'll just enlarge it a little bit by changing the Y limit. Let's see if we put that to 2000. We'll see that part a little bit bigger. Misten is there. There you go. So there you see the first outbreak in the Netherlands in the early year, and you see the blue data is the actual data, which you recognize probably from the earlier graphs. The orange one is smooth data. That's how I took out this sawtooth pattern. I always take a week average there. And then I fit this green line to that data. And you can see it fits pretty well, and you can look at all the details, obviously, to see if it actually fits well numerically as well. So now I have a kind of description of my data. This is a model, and it may not be the model that you think of as a data scientist as what you usually do, like you have an output column and you have input columns and you model something like a neural network to it. But this is also a model. I mean, it's a different approach. It's a time series, but it's also a way of modeling. Yeah, and then I already saw, obviously, that there's lots more data behind the curve. There's already a second curve shape like effect here. There's a big second wave here where it really goes through the roof. So what I did, and that's another a big part of the investigation that I did, I tried to do this repeatedly. So I developed a little algorithm that says, okay, I'm going to assume that the first outbreak is gumball shaped. Take that out of the data and then see if you can find another gumball shape for the second outbreak. Yeah, and I developed that based on those assumptions. And this is what came out after, I would almost say after another 2 months, because it was quite some work in parameterizing this in the right way. And what you get here is some kind of clustering, which is based on this first model of which you saw before, that tries to find out what are all the underlying outbreaks in this general curve that we have. So the general curve is the blue one, which is behind all the other curves. You can see it sticking out on the right a little bit here. So that's the blue effect here. And what the algorithm tries to do, it tries to cluster the data into those typical outbreak patterns that you see. Yeah, and if you look at it in detail, you can actually learn a lot from that. If you look at the first part, for example, and I'll just draw the graph until the 1st of July here. That's 2020-07-01. Which should work, yes. So here you see the first part of the outbreak in the Netherlands, and that's a typical pattern that you see. And then you try to tie it to the reality, of course. Is this something that could have happened, obviously, or is this some weird pattern that I found, which is only mathematically? And then you see, for example, in the Netherlands, you see this typical first smaller outbreak, which is the green one here. That is probably what I've seen in lots of countries and investigating it. Probably people coming from outside the country starting the infection in the Netherlands in this case. This big red one by start date and also by size. The size information is just a little bit above here. So you can see there's almost 30,000 infections in this wave. The size and the shape and the date relate very much to the carnival that we had in the Netherlands, which was a big outbreak of COVID. Here you see a couple of the larger cities following. If you look where these cases actually are and the timing of them, that's probably what happened there. There's a small one here that I can't really place, but I haven't looked in all the details. But then further on, you see here, you see 3 following waves after this larger one. And if you look at the start dates, it is more or less, this one starts more or less 1 week after Mother's Day. This one starts more or less 1 week after Easter. And this third one starts more or less a week after the Whitsun weekend, where we also had quite some large demonstrations in the Netherlands. So yeah, you'd have to verify this with an epidemiologist and perhaps even a behavioral specialist to find out did people actually how did people actually behave at that time? Because yeah, you are looking at human behavior here. But yeah, it might very well be that these waves, these outbreaks can be tied to certain events or certain behavior in a country. And that's exactly what I'm trying to do with this kind of model. It doesn't give you the answers right away, but it tries to prompt you to further investigate and discuss this with the people that that are more expert in this area, so the real domain experts, which I did, and yeah, it seems to make sense. And then the nice thing is, for the last wave that I shape here, you can also see how it will probably project into the future. And that is also a limit to the prediction power of this kind of stuff. I cannot predict a new wave because that is depending on human behavior. For example, if there's a big party, illegal party there somewhere next weekend, I can't predict that the party will be there. The only thing that I can do probably after a week is see that there will be a new wave of outbreaks and model that further into the future. So I can project the current situation, but obviously I can't predict what's going to happen. That's also a limit of the input data. I mean, I'm still working with these 3 columns: date, number, and region. So that's this is about everything that you can get from that limited amount of data, I would say. And you can also see that we have a very steep downgoing trend in the Netherlands, but it is there's a worrying bulge here where the downgoing trend is being broken. So probably in a couple of days, there will be something like a new wave fitted to that, where I can try to find out how big that is and what will happen. Yeah, so last thing, it's almost 7, and I've already told you quite some stuff here. Communication is here again. I mean, this is eventually the graph that I use to communicate. And then what I did is I decided to calculate this for all countries in the world. So believe me, I've got lots of afternoons staring at all these kind of graphs. And then I tried to think of a way to present this data for all countries together. Yeah, the obvious solution there would be a map. Luckily, there's lots of Python procedures and libraries available for mapping data. So I found Folium, which is a very nice one. There's lots of others as well. There's a whole GeoPandas library as well for complex analysis. But Folium enables you, if you get your data in the right format, which is quite a nightmare because you have to have it exactly in the right format. But if you get it that way, you can eventually easily plot it on a map. And I'll show you what comes out of that. So this is for all dates, for all countries, the infection data worldwide. So you can see starting in China, not that big of an outbreak relatively. So these are all absolute numbers. You can see Europe following, US comes up. You see that Russia comes up now, Brazil, it moves to the Middle East. India starts there, other parts. South Africa comes up for a while, but luckily it also goes down again. And you can see the second wave going into Europe here. And you can see that it really starts breaking out there again. And Russia comes up again. We hope that their vaccine will work, but we haven't seen any signs yet, to be honest. And you see that the date here actually runs 1 week into the future. So it's projecting as well. It's an interactive map, so you can also zoom in into it and really see what's going on in the countries. So yeah, this shows you all the data that I gathered and all the modeling together in one display, which is something that you can have a look at to see how stuff works. But it's obviously also a discussion picture with the experts. Yeah, to try to understand what I'm looking at, because I can see stuff moving from the Middle East back to Europe, but what actually happened there is something to discuss with an epidemiologist, I would say. Yeah, that's I guess you won't do this all day, every day, and all of this in one day, but these are typically things that you work with: data, visualizations, modeling, a bit of research into the subject area that you're working on. Yeah, I would say prepare for that and stay curious.
Thank you very much, Damiaan. Thank you. It was a very detailed talk.
Yeah.
A very good view on what a data scientist or machine learning engineer could work on. We don't have that much questions, but we do have a few, of course.
Yeah, sure.
One of the questions is, what kind of factors will you consider in order to predict the outbreak?
Yeah, if you really want to start predicting outbreaks, then the problem is here that you're really looking at human behavior, which is very hard to predict. And also, I looked, for example, in the severity of the outbreak related to the measures in the country. So for example, if there's a lockdown, do I see less of an outbreak than I would expect, for example? So does the lockdown influence the outbreak? But you're always looking at an indirect effect. That's the whole problem, because a lockdown in a country with a culture like Japan, for example, has a much different reaction from the people, a lot different behavior than if you do a lockdown in the Netherlands. So it's almost impossible to predict that kind of stuff, to be honest. And it's also very difficult to exactly find out how measures would influence that. That's so much a cultural and a human behavior thing.
Yes.
That prediction is almost impossible here.
Yes, I understand.
Yeah.
Someone else is asking, it was like, I think 5 to 10 minutes ago, if you were using the Gaussian mixture model.
No, I can understand that it reminds you of the Gaussian mixture model, but I did a different approach because I used a different distribution. So it's not a Gaussian mixture model, but you could represent it with a Gaussian mixture model, if that answers your question.
Ah, okay, yeah.
But that's a pretty technical answer.
Yeah, right.
So no, but you could, yeah. Yeah.
Well, thank you, Damiaan. It's exactly 7 o'clock. So we are actually done with our first Data Science Career Summit. Thank you very much for your time. And I hope you will join us next time again, maybe next year.
Sure, yeah. Would love to, yeah.
So thanks again. Well, we finalized our Career Summit. As I said, in 2 days, we had like hundreds of visitors from really like literally people from all over the world. I'm here. Yes, you can see me, right?
I stopped sharing, so I guess so. Yeah.
Okay. Well, yes, I'm there. So I hope you enjoyed it all. I want to thank all the speakers and all the attendees for both today and yesterday. It was really exciting to organize and to host this event together with the European Leadership University. In case you are considering studying data science, have a look at elu.nl, and for jobs and events and the data science career blog, go to itunes.co. I hope we will be back next year. Well, we will make sure that we will be back next year. So see you then. Thank you very much and bye-bye.